Good evening, everyone. We're back after a week off. Tonight, we're going to talk about solving space junk. And I tried to make it as clickbait a title as I could get it. And I've been finding that seems to be working. The number of views that we're getting on certain of the videos that have been posted on our YouTube site are, one of them is at 78 and the other one is at 52, I think it was. And so, we're starting to be found out. It's not the best kept secret, but there's no actual promotion going on.
Plus, this title is very timely.
Yes, and I actually updated it to include information regarding that event. So let's see here.
I think they are watching you, Monroe, and then doing the stuff so just to prove you.
No, I think if they're watching,
you have some friends in higher places in big countries.
Yeah, no, I think it's just a matter of doing whatever it takes to irritate. Not me, but
Yeah, Sherlock.
The current guy, yeah. Okay, so I'm scrolling through the email I sent out earlier, and it is official. Broward Astronomy LLC now has two patrons on Patreon. So we're moving up in the world. It's up to them as to how much promotion they want to go do for themselves of that. I will say that
I will say, if you want.
I know it's entirely up to you.
Okay, I am a Patreon member. Yay! I'm so happy about it. And
Joanne was the first.
And I joined as a second. Yeah.
And Manuela is the second, but not a number two. She is the second.
We discussed it together, Manuela and I, and it was just a matter of moments, of who was going to be first and second. So we really are right together and in this historic moment of becoming Patreon
members.
Yeah, well, I mean, they have been members since the inception of the group, but they're my first two patrons.
But they usually have like charter members. I don't know how long you have to be a member to be a charter member, but I know I'm a charter member of another group, and it's very nice. They rake you there because you're it's like you get a notice of that you're been one of the people that helped start it, and help support this group. So anyway, it's a really neat thing, and you don't have to that when you go in, I would prefer, but Monroe told me that he doesn't have control where you could just pay so much money for the whole year and just get it over with. No, it has to be you have to do it on a monthly basis, but you can start and stop whenever you want. Yeah. And that's one of the advantages of it.
And there's no set amount or tiers, because aside from these sessions, at the moment, I don't have anything special to offer people that pay more. So it's not a huge outlay. Let's just say it's less per year than I think the cheapest streaming TV service I've got.
Yeah, but you can make it $1 a month if that's what you want to do, or $2 or $3, or it pops up to say $5 a month, but you don't have to change it. You can put it for more.
That was the other thing is I provided them very little input as to how to do it or how to accomplish it, because I really wanted their personal experience as to what the stumbling blocks might be to accomplishing it. Because they're my customer voice.
It was hard. It was hard for me and Manuela. The first time we went in, it didn't work, and then we went back and tried again. And I know Manuela had some other issues with it. What did you have a problem with, Manuela?
My name popped up and was misspelled, and I tried to correct it, and it didn't let me do it. Not for anything in the world. So I quit on it, and then something else was there. So I said, do it next day. And so the following day, everything was easy. No problem. It didn't ask me for a password either.
No, it remembered your connection information. I'm surprised that they're not doing dual authentication where you have to respond with a text from your phone in order to confirm it's really you.
Oh.
But I would say if Patreon is becoming popular, then look for them to do that. I will say that the concept of being a patron of an information provider is now so popular that YouTube is offering a competitive service to Patreon that's integrated into YouTube. I've noticed 2 YouTube sites that now say, well, you can, send money to us via PayPal, but that doesn't sort of get people on the hook for a recurring per diem. Or you can, connect with us on Patreon, which is what I've chosen. And now I've noticed some of those same sites saying, or you can become a YouTube member and get to see videos a day in advance. Well, these are not pre-recorded monologue kinds of sessions. So, since they're interactive, how would you do interactive a day in advance? Because then on Saturdays it'd be pre-recorded and not interactive. And I think that loses something. So we'll continue to do it in this form.
Now, am I correct on Patreon that there is no way to access anything from there? I couldn't see that you have anything on there other than to sign up to be a Patreon member.
There's a 2-step process. The first is you can discontinue your patronage of my account. And then once you've done that, then you can basically delete yourself as a member of Patreon. But I think as long as you have at least one patronage going on, it will not let you delete your Patreon account.
Yeah, but I mean, I don't want to delete my account, but I was just wondering, like, I couldn't get to videos from there.
Oh, no, they're on YouTube.
Okay, so there's nothing there on there. I was thinking that you might have something on that site, that would, but there isn't, right? It's just to get okay.
Yeah, the way it's set up is we do the live sessions interactively on Saturday nights. They get recorded. I then take that recording and spend several hours, times whatever the duration of it is, to clean it down to roughly 2 to 3 hours. And then I post those publicly on YouTube. You can always go to the YouTube site and look at those anytime you want. All of the videos are intended to be public. So if, for example, you don't like being recorded at all, then when the recording announcement comes on, you can leave the session. But that kind of removes all value from it. But if all you want to do is watch the edited videos, you don't even have to participate on a Saturday night. You can just, the videos on the YouTube site are publicly accessible. There's no fee to watch them. So you can just watch from there if you wanted to. And that was what I was expecting the public to do. But as soon as I put videos out there that are more than about 15 minutes in duration, you can see from how much people watch it in the management statistics that a lot of people start watching the video thinking it's going to be your average 15-minute YouTube monologue. And when it starts getting longer, or we don't directly cut to the chase and you have to sit through an hour's worth of news first, you can see people bailing on it. And that was why I was thinking to set up another YouTube site that was more clickbaity, that had only 15-minute duration monologues on it with no interactive content. If that's something that more people that are YouTube aficionados want, then I don't mind spinning that off, because that is all pre-recorded and edited. And that's typical of what you'd see on the videos on YouTube. Is they're all, monologue, pre-recorded and edited. So you only get to see the good stuff, except when the trailer is running. And when the trailer is running, you get to see all their bloopers, or at least the bloopers they're willing to show you. Anyway, So that's the YouTube site. And now we'll get to the news. We were off for a week, so there's a lot of additional news to cover. While it's been announced for a while, NASA does have this mission called DART, is the Double Asteroid Redirection Test. Now, it's kind of mixed messaging because Double Asteroid Redirection Test makes it sound like this one spacecraft is going to 2 different asteroids. It's not. It's going to one asteroid that actually has a moonlet, they like to call it. It's basically the asteroid has a moon. And so it's going to go to the moon of that asteroid and have a known speed and trajectory and impact that moon of that asteroid to see how it changes its orbit. Now, the spacecraft is not that big, but it's going to be moving at, you know, a few tens of thousands of miles an hour when it finally impacts this moonlet. And the moonlet is small, the asteroid is small, so it's a very small scale a demonstrator for, you know, NASA does a lot of technical demonstrators or technology demonstrators. This is a demonstrator such that if the Earth were going to be hit by a comet or an asteroid, and we wanted to not destroy the incoming object, but merely redirect it, how much force would it require, you know, F equals ma to impact the incoming object and to redirect it onto a safer trajectory? So that's what it's really trying to do is, if we know which direction the spacecraft is going and how much mass it is and how fast it is going and where it impacts, and we know previously the orbital characteristics of this moonlet of this asteroid, then how much did it affect it? So they already understand the astrometry, which is the, you know, orbital calculations of astronomical bodies and propulsion and such. So they understand the math. They just want to see if it holds true in reality. So they're going to send this solar-powered spacecraft to go crash into a moonlet of an asteroid. And my first thought was, what gives us silly humans the right to go disrupting this lovely 2-body system that's been there for probably longer than we've been on this planet? And the answer is obviously because we can, and because we want to, and because we created the technology to do so. So, you know, what gives us the right? Because nobody's stopping us. So anyway, that's DART.
So the one little comment about that is that whenever you have anything orbiting something else, it's easier for you to calculate the mass. So a choice like that is because we are sure of the ephemerides of the asteroid, and also we can calculate the mass a little bit more precise because you have a moonlet orbiting it.
But we have not done any surface observations to determine if there's any bacteria or other forms of primitive life already on this moonlet, or if because of our trajectory change, the moonlet crashes into the asteroid. We haven't performed similar observations on the asteroid itself. So we could be destroying the only life in our solar system beyond the Earth, and we didn't bother to look first. But like I said, it's because we can and nobody's stopping it. Anyway, the asteroid is about 11 million miles from Earth, so it's very unlikely that this impact will change either the moonlet or the asteroid to come hit us. So we're doing it safe. Okay, there's a number of commercial rocket builders out there. One of them is Astra, and Astra has tried, this is the 7th time, to put something up into orbit. They don't carry heavy payloads. They're more like small research payload grade stuff, and they launch it from Alaska. So they're really intending to have polar orbiting or polar sun synchronous orbiting. And early this morning at 1:16 a.m., they actually launched an object into polar orbit using their rocket. As you can see here, it's not like the world's biggest rocket. It's a fairly small looking rocket. But they did it. They successfully did it. 6 tries to do it. But you know, even NASA took a few tries before they got something up. But the interesting thing of this launch is, I guess NASA and the US military didn't have complete faith that this would go off without a hitch, because what they launched was a dummy payload. So it's about the same rough size as typical satellites to be launched by this rocket. And it's towards the top end of its payload capacity as far as weight, mass goes. But it's just a non-functioning mass. It's a weight. So yeah, they successfully put a piece of space debris in orbit. Now it's in a low Earth orbit, so it should fall back within, I don't know, a year or so. But here we are purposefully launching a bit of space debris, but it's not scatter debris. It is a solid object, and we will track it on radar. So it will have a defined orbital characteristic. And I'm presuming that given that it was a launch by NASA and the US military, that the FAA was involved and the Space Force was involved. So they're going to know where it is, and they approved of its orbital characteristics and what orbital slot it's going to be in before they ever attempted launch. But yay, there's another commercial space venture that's leaving the Earth. Well, at least going up into orbit, that I mentioned a couple of weeks ago. But if you were looking at the releases from NASA this week, they showed you lovely pictures of the larger planets of our solar system. And they were wonderful pictures, and they were taken by the Hubble Space Telescope in September of this year. So it's not current imagery, and they were actually released to the public individually when they were taken, but they've gone and done kind of this lovely collage of them where they all appear in the same picture. And if they were actually that close to each other, it would be a celestial disaster. But they showed it off as if it was current stuff from Hubble, and it's not, because at the moment, they're still working out the problems of their data synchronization issue between the mission control computer on board Hubble and the instrument computers on board Hubble. So there is only one camera that's working on Hubble at the moment. I don't know the total number. I didn't update it when they did the final shuttle mission.
So what are they trying to prove here in September? I know it's not now, but
no. Back in September, they were just doing planetary observations, and at that particular point in time, everything was in the right position for them to do a grand tour. So if you remember back when Saturn and Jupiter were in the night sky together, well, Neptune and Uranus were also there. So in a single set of observations, Hubble could take pictures of all of these things, and they would all be in lovely viewing. You know, the red spot was there. The rings of Saturn were just the right angle. It was all great stuff. In fact,
it is great.
Yes,
they're beautiful.
You can even see the dark spot back then on Neptune.
They're amazing pictures.
Oh, yes. I'm not doubting that. I'm just criticizing NASA for taking old information, repackaging it, and then announcing it in a press release as if, look what we just did back in September. Yeah.
They did something. They put the files together and reprocessed it in one pretty picture.
Yeah, instead of it being separate pictures, they made a collage.
Yeah, yes. And you don't like the collage as being the story.
No. What I don't like is them taking old data, putting a new publicity wrapper on it, and then basically making people think that Hubble is back working again. Look at these new pictures from it. And they're not. They're from several months ago before it had problems.
So Hubble, they'd always predict Hubble would have problems, but Hubble's problems that they're having now is something that can be overdone, or is Hubble going away?
It's not determined yet. The best way to describe it is if you had a camera that was on a USB connection and your computer couldn't keep up synchronization with the USB connection to the camera, it would drop data and lose connection. And that's what Hubble's having right now. Is when they corrected their previous issue with Hubble, which was supposedly a power supply issue, everything was fine once again. And then all of a sudden, the main scheduling computer on Hubble started getting out of synchronized data from the instruments. and they had no explanation for it. I think that there is a speed of processor issue where the main computer that they're now running on Hubble is not performing sufficiently fast enough for the data that's streaming over the interfaces from the science instruments to the main computer for delivery down to the Earth. And in order to try and debug that, they put all the Hubble instruments into standby state, and they took an instrument that had not been in operation for 10 plus years, turned it back on, and tried some, playing some software games with it to see if they couldn't solve the synchronization issue. And they thought they did. And then they applied that resolution to one of the current instruments on board Hubble, the Advanced Camera for Surveys, or the ACS. And they were able to get that instrument back working again. But if they were able to get more than that one, then they would have said so. What they actually said was, the team is currently working to recover Wide Field Camera 3 to operational status next week. So they got one instrument running. They don't seem to say how they got it working again. They just say that they resolved the issue relating to missing synchronization messages. That's basically a kind way of saying they got out of sync and they were dropping data on the floor. Well, if that solution really worked for all the instruments, they could bring all the instruments back online. But if they have to do it differently for different instruments, because different instruments can deliver data at different data rates, yeah, they've got a problem with the central computer on board Hubble, and it seems to be a performance issue, and that could be due to many things. But we'll let them figure it out. I just don't appreciate, them in the meantime making the public think that new stuff's coming down when it's not. I would rather they, were truthful with the public and say, hey, we've still got a problem. We've got one instrument working again. Here's the instruments we have yet to get working, and we're working on this one next. I would say, great job, NASA. But this is a PR confusion.
Yeah, but I can sympathize to some extent that this is maybe their last picture that they can get from Hubble. So they're making the most of it.
Well, yeah, this is the Digital Trends website. This is not NASA's website. If you want to, you can actually go on the Twitterverse, if you're into Twitter, and you can actually follow NASA Hubble, and they do put out updates. So you can follow those things.
Oh, so you're saying that they may have other things coming from Hubble?
No, I'm saying that the Hubble engineers on the ground, as they find problems and are working solutions, they will update the Twitter messages. This particular image is not taken by Hubble. This is taken by the shuttle after, I think it was the second servicing mission to Hubble.
Oh.
So that's a really old image. Except the tweet says November 16th, 2021, which makes you think, oh, that picture was taken November of this year. No, it wasn't. That picture is over a decade old.
How did you figure that out? Just because you saw that picture? I mean, how would it be different from one picture to another? Okay,
there's two things that gave it away. The first is, well, obviously the camera that was taking the picture was near Hubble in orbit. When was the last time we had anything near Hubble in orbit? Well, that was the third shuttle servicing mission to Hubble. But when they did that, they put on higher tech solar panels. You see these solar panels? They look kind of classical, rectangular 2-panel kind of things. And the newer panels are a bit larger and they look more orange in color. They're more contemporary satellite solar panels.
Wow.
So that's how I knew.
Wow.
Second servicing mission. Also, the other thing
that is not that big of, big difference. You are very observant.
Well, the other thing to notice is, look at what Hubble's doing. Hey, the front door is open. It's observing. So this was a test observation after the servicing mission. So they were in orbit with Hubble, keeping an eye on it as they checked it out. Yeah, I noticed
after they service, don't they let it sit for a long time to stop, you know, the shakes and the jitters?
Yes, and because when they service Hubble, they actually grab it, and it became you know, a single object with the shuttle. And then when they release it, and they have to wait for it to not only stabilize, but because it was not able to orient itself, it has to temperature adjust itself. But they've already got the front door open. So, you know, the sun is obviously to the back of us because otherwise we couldn't see Hubble. So it's pointing off into deep space, trying to gather an image, which would probably be, you know, a day or so after the servicing mission. Yes, I'm good at connecting dots. I take the information that's made available to me and I go, oh, I understand. Anyway, that's Hubble. Ingenuity, the little helicopter on Mars, took another flight last month before they had to shut things down because of the opposition of the Earth to the sun to Mars, because we can't communicate with Mars when it's behind the sun. So they took a video of it. The Mastcam Z. This is the camera that can like poke its head up off of the Perseverance rover and tilt up, so it could actually take a picture. Actually, took a video of Ingenuity flying, and I don't know that we can see that. Let's see here. I don't think this is gonna work right, but you know, we'll find out. It's about a week behind. Yeah.
Oh yeah, there it is.
Little blob. Yeah, it goes off screen and then it lands. Takes a couple of minutes to watch it. There it goes, zooming across. Cool. Hey, it's out of frame. Well, remember the Perseverance is robotic. So when it went out of frame, it's not like somebody on the ground can say, adjust camera to the right, because that would take 36 minutes. So it comes back into field of view. It hovers and then it descends, and it actually hovers above the ground for a little while, sort of blowing the dirt out of the way. And then it settles down.
That's a good idea.
Yep. So this was flight number 13 of Ingenuity. Flight number 14, if you remember back to, they tried to lift off, and the tilt on the rotors here was not responding as expected. The motors that were tilting the rotors didn't seem to be doing what they were told to do. And so they discontinued flight 14 early, canceled it. Then flight 15 is expected, sorry, flight 15 was shortly before we lost contact with Mars. And then after that, we've got another flight 16 that is scheduled for maybe today, maybe tomorrow, depends upon circumstances, everything else scheduling. But Ingenuity is still working fine. They found that they could rev up the speed of the rotors to compensate for the reduced atmospheric pressure during the Mars summertime. So that's working. If you look really closely, it's kind of hard to see, but if you look at this foot of the helicopter, you'll see that it's kind of orange along this edge.
Yeah.
The surface material, and you can actually see it over here as well. The surface material of the carbon fiber feet is picking up the fine grained glass-like dust off the surface of Mars as it lands. So when it lands, it kind of hovers, stirring up a cloud of debris, and then it lands in that debris, and then the debris settles back down on top of the feet. That will gradually increase the weight of the helicopter. And they're trying to decide how to compensate for that. Because remember, this thing is not designed to carry massive loads. It was specified that you have this much battery time for this much weight at this much RPM, and you can fly this high and this far for a flight of this duration. And all of that was calculated out to the nth degree, except they didn't count on Martian dust weighing down the helicopter by statically clinging to its feet.
So the winds from the rotor don't clean that off?
No, because it's a static clinging. It's not just settling. The carbon fiber is carbon. And you can have, as the rotor spins, it'll generate a static field. If you've ever seen The Hunt for Red October, you'll know that it's not a good idea for a helicopter to try and make contact with a metal submarine on the ocean. The differential current of the static of the helicopter blades rotating around in air it's generating thousands of volts differential. Well, here I doubt that it's thousands of volts, but it might be hundreds of volts. But it's a very, very low amperage, but it's sufficient to charge up the carbon fiber legs to the point where as the Martian dust settles, it will actually cling to the feet. And it's not like it's going to wiggle its feet and get rid of it. And when it spins the prop to take off, there's not enough air pressure to make it blow this statically clung glass off the feet. So it will gradually increase the mass of the helicopter. But it's just something that they're thinking about what to do about at this point. But I just thought a weird side effect. And also, if you look right here on the blade, since the blades have a static field, it's actually collecting Martian dust on the blade. Even though the blade is running at, what was it, 27,000 RPM or something, it's still, clinging to it. So it's just slowly getting, fractions of a gram heavier every flight.
That what you make me think of, and I thought of this before, is that there was a lot of contests prior to going to Mars for people to build drones to go to Mars.
Yeah.
And I wondered why they didn't do a drone instead of a helicopter. But I don't know if it would be any better with this electromagnetic thing, but it makes me think, well, they had these other things that they were thinking about.
There were a couple of things they had to consider. This particular kind of helicopter is called a counter-rotating dual-blade helicopter. So it doesn't just have one set of blades here and here. Underneath it, if you look closely, you can actually see another blade here. So it's actually got two sets of blades that rotate in opposite directions. You only need one motor and a gearing mechanism in order to accomplish that. You do not need a tail rotor like a regular helicopter that has a tail rotor and a rotor on the end of the tail to stop it from counter-rotating. And you only need one motor. You don't need 3 or 4. So it was all about how small and lightweight they can make this thing. And this is the design they came up with. So
Thank you.
Yeah, it's a technology proof of concept. And I think they were very, very successful at proving the concept.
It was supposed to be used just for like 24 hours. So it overpassed. It's used like it's programmed used already, a proof of concept that you can find things on Mars.
Yes. And also now they're getting more and more risky with the kinds of flights that they're doing. And I suspect at some point, I'm going to say that the tilt mechanism on the rotors, that gearing will probably succumb to wear from Martian dust because it's glass-like, and these things are printed carbon fiber, 3D printed carbon fiber. So it's going to wear down to the point where they can't get the blades to tilt as expeditiously as they expect. And if they're lucky, they'll just sit the helicopter over in a corner and wave goodbye to it. If they're unlucky, one of the props might actually shear off, given the high RPM and the fact that the carbon fiber is getting eroded. If you remember looking at Curiosity has aluminum magnesium wheels, and the actual surface of the wheels is now abraded to the point where you can see holes through them. And that's just Curiosity, running traction of the wheels against the Martian glass-like soil for the last few years. So
Helen, did Helen say that this helicopter, they spent all this money just to have it go up there to see if it could fly?
Yes.
And
yes.
Yes. They were only expecting it to fly it for at most 3 trips. And it literally was going to, the first trip was just spin up the props to see if it won't self-destruct. That was the first one. The second one was spin it up and hover less than a meter off the ground for a period of, I think, 30 seconds, and then land and do that successfully. And that proved out a lot of the structural and aerodynamics of it. So the third one was to lift off, hover for a few seconds, go up to 15 feet off the ground, move to the side 3 meters, come back, and then land pretty much near where they took off from. And they did that successfully.
I'm looking here.
That was all it was supposed to do.
I'm looking here on the page, the key objectives. So prove power flight in the thin atmosphere of Mars, demonstrates miniaturizing flying technology, operate autonomously, how you pronounce that? Autonomously, because you have to program first, then it flies by itself. So yes, you cannot control from far away. And then, yeah, key features. Yeah, that's basic stats. So it's a proof power flight in thin atmosphere, demonstrate miniaturization of the technology, operate autonomously. So you have to think about that it is a very small object, but it has enough equipment. But it actually reads where it's landing, reads where it comes out, reads where, so you program, and then the robot decides what it's going to do by the program. So for that to be fitted out in something that's smaller than a shoebox is like really
amazing. That is concerned about this clinging. What would we do if it was clinging here on Earth to his legs? I mean, to his feet.
No,
is there like the baking powder on?
We have enough lift.
Well, remember, they did test out this helicopter. They did test out this helicopter in a pressure chamber that simulated the Martian atmospheric condition. The problem was they didn't simulate the Martian dust, because that would have damaged the pressure chamber, because the Martian dust is like fine ground glass. So they're doing the proof of concept, and they're finding out more things about the nature of trying to operate a helicopter on Mars. The one thing that came out as a plus was, after it proved itself out as the technology demonstrator that it was and accomplished all its goals, and it was still operational, they said, now what can we use it for? And they on the fly came up with this concept of, we'll have the helicopter fly ahead to take detailed pictures of the ground to give us more information about where we want Perseverance to stroll off to. So that was created on the fly, and they found value in that. The helicopter can spy out rocks that the rover might want to look at, because the rover does not have that high a view. The rover has basically a 6-foot high view. So if the helicopter can see something that the rover can get to that's sort of over a ridge, the helicopter can help Perseverance find new and interesting things. And so that's what they're using it for at this point. But I suspect they're going to push it a little too far, and it's going to have a bad day.
Well, that seems like that's what their goal is, right? To see how far they can push it.
Yeah.
Kind of, but they realize that it has value now, so they would like to have it last a long time.
So it's kind of my favorite experiments. You start, you learn what you need to learn, and by the end you explode it. So that's my favorite thing.
So that's either the Mythbusters philosophy, if it doesn't explode all on its own, throw lots of explosive material in it and blow it up. And if that's not your cup of tea, then SpaceX early missions. When SpaceX is proving out a new rocket body, and the rocket body is meant to contain cryogenically cooled liquid fuels, what they will first do is overinflate it with chilled liquid nitrogen and deliberately blow it out. So if you look at the early the early demonstrators before they ever lifted anything off the ground of the tank that is meant to be part of Starship, they literally filled it full of cool liquid nitrogen until it ruptured and exploded. And they did that on purpose, because they wanted to see, oh, okay, so if that's what it takes to blow it up, we'll only go to 80% of that, and that will be our design limit. So
okay, so I'm looking here again on the page from Wikipedia. By November 6, 2021, the helicopter has made 15 successful flights, and it was programmed to do 5.
Well, actually, it's made 14 successful flights, because one of the flights never lifted off. They canceled it before it lifted off. Actually, the helicopter canceled itself. But today or tomorrow, they will be making their 16th flight. And I suspect it's going to be successful, because they understand what it takes. So up until they get a material failure, most likely due to abrasion from Martian dust, they're going to keep doing things with it. And I think that's great.
Yes, I do too. That's wonderful.
About a month ago, they did have a video, not a video, two snapshots. They showed the silt, the glass-like material underneath the helicopter. This was before it went behind the sun. They showed the material beneath the helicopter before, and then when the helicopter took off on a mission and came back and landed on the same spot, they showed the same area. Like, what does the ground look like before and after? There is so little air pressure on Mars that even things as small as the lead of a pencil would not move. It was still sitting on the surface when they came back and landed. So only the very finest dust, very fine dust, was actually being stirred up by the helicopter. And that explains the ability for that dust to be more likely to cling from static electricity.
Okay. I'd like to do a hypothetical. I know this isn't real, and you'll point it out. That can't happen to me. But
what
if we could, if there was a possibility that we were on Mars and we could make like a slab of cement there, or a driveway or something, would this help the little helicopter with this static cling that he's having?
Yes, but here's another thought, and products actually have this: a ground wire. So if the helicopter had trailing off the bottom of one of its landing legs a very hair fine thin conductor, copper, silver, something like that, and that made contact before the helicopter touched down, that would remove the static charge from the helicopter before it landed, so that by the time it landed, the dust that it stirs up would not have a static cling to the feet.
Yeah, so it could drag a chain like the big trucks do. Yeah.
Like trucks. So what, I mean, that sounds even simpler than my idea. So why don't they do that? I mean, that doesn't sound like it'd be hard to do. I mean, making a little slab of something up there sounds like a complication to me, but they must have little things like that up there, some copper around.
Well, not for this mission.
Okay.
Because they've got nobody to attach it.
Well, they got that perfect, whatever it is, that running around.
No. I'd say it's something to add to their next time we do this.
Now they know that
I think it makes sense for them to add it to next time.
You have a flying object, so you can plan even better.
Yeah,
missions.
that's true.
So you don't have only satellite data.
Yeah.
So we know better. John wants to talk something.
I guess I
was talking about attaching a chain to the helicopter. Yeah.
Yes, but a hair fine piece of copper wire would degrade given the sharpness of the Martian soil. I keep wanting to find another word than soil, because soil denotes, like, loam, things you can grow crops in, and it's not. But I don't want to say Martian dirt, because dirt sounds like it's a larger granule. Martian sand. I mean, Mars does have sand dunes, but they're ground glass. Yeah. Martian dust. Okay, let's get on the show.
Is that the moon?
What was that?
Can it be megalith, or is that just for the moon?
No, regolith.
Regolith is for the moon.
But I think it could work for both. I'm going to look them. I like the question.
Yeah, until you start looking at it, a lot of people will reuse Earth-centric terms for non-Earth-centric similar observations. Like if you say, I've got a satellite that's orbiting the Earth, and it's at its maximum altitude right now, so that's its apogee, right? Well, yeah, but if it's the moon orbiting the Earth, that's its apogee too, right? Well, kind of.
No, David's right. So I'm reading the definition. Soil has organic material, and regolith is inorganic. So that's the perfect word for it.
Okay, I'll use regolith in the future. The problem will be people go, is that Chef Boyardee? No, that's rigatoni.
Ravioli.
Ravioli, yes. But regolith, yes. Sounds like regolith is the appropriate term.
Regolito.
Regolito.
And you'll remind us, you'll just say it's like glass. You'll say it's ground up glass, and then we'll know.
Yes. That's the best way to describe it. It's like fine ground glass, and it's coarse enough to grind down a magnesium aluminum wheel to nothingness.
But I like regolith. I like that word.
Regolith is the correct term.
Yeah, that's very good, Joe.
I was watching a video from Doc Brown, as I like to call him, Mike Brown, the guy that finds all the not the exoplanets, the dwarf planets in the Kuiper Belt and further. And he's now looking at old data to see if Planet 9 was actually recorded years ago. He knows generally where to look. It's somewhere, if you're looking up in the night sky, it's somewhere between Orion and Leo. No, Taurus, Orion and Taurus. There's a swath in there that if you go off Bellatrix towards Taurus, that's the area that they have left to search. They ruled out all the other parts of the sky. And now they're looking at old data from previous observations, and they started looking at some of the infrared data that was available from other surveys. And what they're finding out is the data is not that good for what they want, because the infrared data is from surveys meant to find stars and galaxies. And if you're a planet, 8 billion miles or so away from Earth, you're going to be very small, very much smaller than a galaxy would appear. You're going to be very dark. You're not going to be very bright because you're going to have a lot of carbon on your surface. Your atmosphere is going to be so cold that it's likely to have frozen to the surface. So you're not going to be very reflective with the carbon sitting on top of it. So you've got basically a dark spot in the sky. And if it's that far out and it's on a very elliptical orbit, if you were to take two pictures a couple of days apart, you might not even, if you were doing a blink comparison, you might not even notice that it moved at all if you could see it. So you might think, oh, it's just another star. So we may have in existing infrared survey data what we think is a star that's actually Plan 9. But that's what Konstantin and Mike are looking at the moment, is already recorded data. Plan 9, we may have already seen it and just not realized it. But I was saying this a while back when they said, we would have found it by now. We've done infrared surveys of the entire sky. And so I actually sent a question off to one of the technicians that was working on those cameras. And he absolutely came back and said, the pixel size is wrong. The focal distance is wrong. No, we just wouldn't see it. It was kind of like having blinders on. So that's the way I like to look at it, is like having blinders on. You have to look for what you want to look for using the correct instruments at the correct places. And in that regard, I sent an email off to our subject matter expert for our James Webb presentation. And I asked him, would it be possible for the Webb to look in that part of the sky and, examine it for a planet? And he said, yes, because, the Webb has the right kinds of instruments. The problem is the Webb is not good at wide field. It can't take big pictures of the sky. It can take, patchwork quilt pictures, but that would consume a lot of their observation time. So if somebody else can say precisely where to look, then the Webb can actually take pictures of that planet in the Kuiper Belt. So if somebody else finds out where it is and calculate its orbit and predict it, then they can task Webb to go take a look at it. But remember, the Webb might not be pointing into that part of our solar system, except at a certain point in the year, because it's at the L2 point and it orbits the sun with the Earth. So
did you say in the Kuiper Belt? Because I thought they had to clear the Kuiper Belt to be a planet.
Well, the presumption is this is a dwarf planet, so it would not have cleared it. But given that it might be as far away as 8 billion miles from Earth, it could be well outside the Kuiper Belt. Also, it could have a very high inclination of its orbit. So it could be well above the orbital plane of the solar system. So it wouldn't be within the normal debris field of the Kuiper Belt. But until we find it, we won't know.
We're not numbering dwarf planets, are we?
Oh,
well, I was discussing that with Helen. I was discussing that with Helen.
You start with Mercury, Venus, Earth, Ceres, Mercury, Venus, Earth, Mars, Ceres, Hygeia, Jupiter, Saturn, Uranus, Neptune, Pluto, Haumea, Makemake, Eris, Orcus, Sedna. Ooh, I haven't memorized those yet. Quawar.
Yeah.
Yeah. So I still have to memorize the ones back, but the numbers it's higher now.
I look at it like the periodic table of elements. There were a good almost 10 elements that we had predicted but never actually observed in high energy machines and, you know, cyclotrons and such. But they were still in the periodic table of elements. And when kids went to high school, they still had to learn the entire periodic table, but we added more afterwards. That's just not fair. Well, it's the same thing. If you find more things in orbit about the sun and they have a defined path and they're big enough to have hydrostatic equilibrium, they're a planet like object. I just think it's going to be funny if they find something in the Kuiper belt that's roughly the size of Neptune, and it's big enough to have pushed all these other things around in the Kuiper belt, and they still want to call it a dwarf planet.
No, I don't think so. It would be a way of the rule, because the rule now that they postulated is that when you are massive enough to control the orbits of other objects around you, you are a real planet.
That's the Jupiter exception clause, because Jupiter has stuff in its orbit called the Trojan asteroid.
It controls it. The gravity of Jupiter order things around the solar system.
Yes. And even the Earth has its own fleet of Trojan-like asteroids. So we should be a dwarf planet, right?
No, because we cleared most of it, including colliding one and end up with the moon.
The rules don't say most. The rules say you've cleared your orbital.
Well, you clear your orbit, and whatever's left is locked to your orbit. So yeah, you're controlling the orbit.
What I really attribute it to is who was in attendance at the plenary session on the last day. The astrophysicists were there. The planetary scientists had all left. I think they had one or two planetary scientists left, but they could not outvote all the astrophysicists who knew nothing about planetary orbits and just wanted to. And
nothing about Greek too, because dwarf planet, it really irritates me a lot. Because
I think it's derogatory.
Used for the collective of, hydrostatic equilibrium bodies, they're not stars. You call it planets or wanderers in Greek. Yeah. If the ones that you have that are a little bit smaller, they are in belts, you should call it planetoid. No, it's a perfect word to use it. And dwarf planet's just stupid.
Yes. Now, Helen, when you were giving your list, Helen, I haven't heard anybody do that before, that they're adding these new ones. Now, were those dwarf planets or are those planets that you're referring?
The ones that you didn't know the names, those are dwarf planets. So in the case of the asteroid belt, there's one of the asteroids that are actually one of my favorite asteroids, Hygeia, that we only have a few little images of the Hubble. They're not well defined. And they were trying to calculate if Hygeia had a hydrostatic equilibrium. So they finally got all the calculations. The data is sufficient to prove that Hygeia is actually big enough to be round. That's what we mean is a hydrostatic equilibrium. So they add in the asteroid belt, that is Ceres, the one that was visited by one of the spacecraft. And you have Hygeia. Vesta, the other one who was visited by the spacecraft, the one that looks like a bumpy thing with a huge crater of an asteroid. That one used to have hydrostatic equilibrium, but because of that huge impact, it lost the southern hemisphere, so it lost its hydrostatic equilibrium. So that one could not be classified as dwarf planet, so it's just an asteroid. But you have to remember that those lists, they change, because between the 17 and 1800s, we have about 18 planets, because all the asteroids that were mapped and visible big enough, they totally had they were called planets, until we figure out there are so many that we figure out there was a belt there, and then we renamed it asteroid. That means star-like, because when you look through the telescope, they look like there's tiny little dots. So that star-like, so that asteroid.
But the reason why all this comes back to light is Helen and I went to see the before the fact Pluto planet killer, Neil deGrasse Tyson. We went to see him at the Broward
promoter of the killing of the planet, because the killer was Mike Brown.
Yes. Neil was an accessory before, after, and during the fact.
Oh, really?
Yes. And he's very proud of having removed Pluto from the Hayden Planetarium planet display, and he's not putting it back no matter what happens. Not even if they change the rules.
What? And then
in Helen's list, it's a dwarf planet, so it would be in the list, right?
Yeah. Get over it. He says, get over it.
Yes, he said, get over it. No, he's not putting it back, because the model at the Hayden is of the planets of the solar system, which doesn't include any asteroid, Kuiper Belt objects, or dwarf planets.
Oh, I was thinking that when Helen gave that list, it put dwarf planets on a different level. It put it with the level of planets then.
No, I think they did it to create a delineation, and it was done by astrophysicists, not by planetary scientists.
Okay.
So, yeah. But I do want them to find Planet 9. I want them to find that it's many more than one moon. And let's just throw in another one. It has continents. And then have them explain to me it's a dwarf planet.
So,
yeah.
Number 9. So we don't have 9 planets right now.
Not that we're aware of.
No, right now the count is 9 planetoids, or dwarf planets. So it's basic 8 plus 9.
We have more dwarf planets than we have non-dwarf planets.
Okay.
I was looking at the Wikipedia page. Hygeia is not in a list. So this is being changed a little bit, because it needs more papers to be published, and you wait for the next meeting for things to get established. So on the page of Wikipedia, we have Ceres, Pluto, Ares, Haumea, Makemake, Gong, Quaoar, Orcus, and Sedna. But the new papers that will be approved most likely will add Hygeia in the asteroid belt. I like Gong. It's a very cool name.
Thank you.
So enough about Planet 9. Okay, so people have often stated that electric airplanes are just impractical. They're never going to happen. Just someday maybe, but not soon. Well, there's a company called Rolls-Royce that makes airplane engines that has recently produced the world's fastest electric aircraft. Now, they didn't make the fuselage. The fuselage was made by different companies with backing from the British government. But Rolls-Royce now has the record, as far as I can tell, of the world's fastest single-engine, prop-driven electric aircraft. It's not a hybrid, it's battery-operated. It's called the Spirit of Innovation. The maximum speed was 387.4 miles per hour, or 623 kilometers per hour. Now, it did that speed over a trap. Now, whenever you're measuring the speed of something, you have a start and an end of a fixed separation, so you can judge the distance over the two trips. And it was only a 1.86 mile trap. That's from one point to the other. And they did it at 345.4 miles per hour. It also attained the fastest climb, ascending to 3,000 meters in 202 seconds. This is the fastest climb of an electric single-engine prop job. It flew at over 300 miles per hour for over 9.32 miles. That's faster than its previous record. So they're making it fly faster. the group that was doing this research is the Accelerating Electrification of Flight project, funded by the Aerospace Technology Institute, that's a company, and then the Department for Business, Energy and Industrial Strategy, that's UK government, and then a separate company called Innovate UK. So the electric motor was a 400 kilowatt motor, which sounds pretty big, but I think the Tesla semi truck is going to have 4 motors of that size in the truck. But if people are saying, you know, electric prop jobs will never be a thing because they can't make an engine go fast enough or whatever, this would kind of counter that. The only holding back, the only stumbling block they have at this point is battery duration. And as we know with the electric cars that they're making those go farther and farther. They're finding new battery chemistries and new battery designs. And so I suspect before long, we're going to start to see electric prop jobs for short hauls. So if today you would buy yourself, you know, the typical Piper Cub kind of thing and go for, you know, 200 miles between private airports, you might find yourself buying an electric plane, which might make it a lot less expensive to operate with a lot fewer controls. Oh, where's my knob for carb heat? There is no carb heat because there's no carburetor. So there'll be a lot of differences, just like there are with electric cars versus internal combustion engine cars. But yep, it's not just cars and trucks and motorcycles, and it's airplanes too. Okay, sometime in mid to late January of 2022, SpaceX will be launching its Starship on board its super heavy booster to put it in orbit. It will be the largest spacecraft ever lifted off from Earth. It'll be the heaviest thing that will ever have wound up in low Earth orbit. We have heavier satellites in geostationary orbit, but that required, you know, the core rocket with the side boosters and 5 of them, and it launched on an Ariane. And you know, we put up bigger chunks of satellite into geostationary orbit. But as it says here, might not be a success. If you know how SpaceX does things, they do destructive prototyping. They're already saying that the upper portion, the Starship, which is this part of it, they're going to land that in the Pacific Ocean east of Hawaii. They're not going to try to recover it because the mission here is, can we get it to launch successfully? Can we get it to orbit? And on its way back down, can it achieve the flip maneuver and then attempt to land? I don't know if they're giving it enough fuel to make it all the way back so it can do a vertical hover above the Pacific Ocean before it drops into the ocean. Don't know enough about that. But I know that the super heavy booster is actually going to be landing in the Gulf of Mexico, and they're not going to attempt to refurbish it, I guess because they're not putting enough fuel on board. They're already stating that the Raptor engines they're using this time out just aren't going to be big enough. The ridiculous extension concept, if you have an engine and you put 1 or 2 or 3 of them on board your rocket, that makes sense. If you put 5 to maybe 8 of them on your rocket, that kind of makes sense. If you put more than 20 of them on the bottom of your super heavy booster, maybe you're doing something not right. Maybe you ought to find a different kind of engine. So they're already predicting that the Raptor engine's days are numbered and that they're going to have to build an even bigger engine in order to make it, I guess, more launch effective and cost effective to launch payloads this large. But I haven't seen any FAA restrictions at this point that would stop them from doing it in sometime in January of 2022. So, the Super Heavy has 33 Raptor engines on board it. The upper spacecraft will have just 6. 6 is a tolerable number. 33 Raptor engines is getting to be a bit extreme. The plumbing on it alone is just a nightmare. To get all the fuel to all the engines equally, yeah. But you've got a huge amount of redundancy you could have 4 or 5 of the engines fail and probably still do fine after launching in late January. Now this one Adam sent to me. There's a physics principle known as the Pauli blocking principle that says if you can make a material dense enough that does not affect photons, because all the places where photons could land and move electrons have already been filled. If you have a stable enough material so that the photons don't interact with it, and there's a dense enough packing of it, the photons will go through the material without interacting with it, which means that the photons passing through will appear as though the light that's passing through the object is transparent, so it will make that material disappear. It'll make it transparent. Now, this is obviously a quantum effect done on an extremely small scale with very controlled conditions, as in you've got a gas that you're making a, what do you call it, a Bose-Einstein condensate. So it's very, very cold, a very small chamber filled with a very tiny amount of gas, but you're proving that you can shine light through it and the light goes through it without interacting with the material. So this is another example of things are weird at the quantum level. So we're now creating the technology sufficient to demonstrate under peer review principles that we have only predicted at this point. But it's not to say that you could kind of wrap your tank in condensate and make your tank disappear, because the photons would still be stopped by your tank. They would just go through the outer surface of it.
This is more for quantum computing, right? Because we still have a lot of problems with resistance, and then you end up losing data. And if you can get photons going through a material and not interact, you would have virtually no loss of data.
I think that they came up with that as a reason for doing this after the fact. They've been working with Bose-Einstein condensates for a long time, and the Pauli principle has been sitting out there for a long time, and they just, did it, but now you've got to have peer review of it. So they've done it a couple of times. I think it's been demonstrated 3 times now in 3 different facilities. So, yep, it's a proven fact.
But when Michael Faraday was playing around with electricity, everybody was saying, nobody will ever use that thing.
Yeah. So until you can scale it up and make it cost effective, it doesn't become practical technology. But at one point, micro electromechanical devices were in that same boat, and now everyone's mobile phone has them. You no longer have little spinning things inside your mobile phone to act as your accelerometer and gyroscope and magnetometer. They're quantum field effect devices that are smaller than a human hair, and they oscillate in the presence of electromagnetic fields, and that's how you detect such things. So we went from, it'll never happen, to, hey, look, we can make this happen at the nanoscale, to, hey, if we can get that cheap enough, those would be really cool to replace the moving parts in those sensors and make them really, really cheap. Well, now you can get a 9-axis, 10 degrees of freedom sensor that costs like 5 cents in a mobile phone. So yeah, I think it's good to be doing this stuff. There are things that we can only demonstrate today that someday we might get to be doing for practical. But right now it's just for scientific research. And how they get it that cold is another thing. So how do they achieve these really, really low temperatures? Obviously, they use mirrors and lasers. They found a few years ago that if you make the laser shine off of a molecule, it will transfer momentum to the molecule. And if the vector for the momentum is counter to the vector of the movement of the molecule, it will slow the molecule down. And everybody knows that, if you have molecules agitating around, you have more energy in the substance, and it makes the substance hotter. Well, if you can cool it with liquid helium, but that's still not getting rid of all the energy from the system, you can then shine a laser in multiple directions and make the molecules slowly gravitate inwards and thereby reduce their motion and reduce their energy. It gets even colder. So if people think that lasers can't make things move, here's another fine example of radiation reflection pressure being used for something practical. People like to talk about graphene as this carbon, thin layer, almost one atom thick kind of thing. They now have a new substance that they've mixed carbon and iron together, and they've got a new metamaterial called magnetine. And magnetine apparently creates something slippery but more durable than graphene. And so they're now saying that someday we may be coating materials that rub together with magnetine and thereby not needing lubricants. And if you remember my discussion on when we run out of oil or when oil gets in short supply, the first place we're going to feel it is on lubricants. Well, if they can quickly bring these things to market, then you may be putting magnetine in your internal combustion engine instead of Pennzoil. Put a push pin in it, we'll see how it goes. But that would be very awe-inspiring if they can make that a commercial success. I just wonder, because there's no registered trademark here. I wonder who's going to get the copyright on the logo magnetine. Puts the slippery back in your car. Put a push pin in it, look for magnetine.
Oh,
And now we have the lead in. This is the lead in for tonight's presentation. If people weren't paying attention to it, every time the International Space Station does an orbit now, which is about every 90 minutes, they have to look out for debris. And the debris is scatter from Russia sending up an anti-satellite missile to explode one of their own satellites just to prove they can do it. And it's created a ever-expanding debris field. And they've tracked over 1,000 pieces of debris. U.S. Space Force has tracked over 1,000 pieces of debris. So they have a plot of all the big pieces and some of the smaller size pieces, but not yet all of the pieces, because you have to do that with radar. And if you didn't know where they were at the time, you have to kind of sweep the radar and see if you see anything that shows up. But if the radar pulse is not strong enough, then you won't pick up the smaller pieces. So, yep, junk in space, courtesy of Russia testing out its military prowess. And
yeah, so can I ask you a question about that?
Sure.
So I understand it's going at like something like 17,000 miles an hour to maintain to maintain orbital velocity. Is that right?
The space station velocity changes slightly, but I've generally heard it spoke of as 19,000 miles an hour because sometimes it'll be a little lower until it boosts itself back up.
Oh, right. So it's dependent not on the mass of the object, but the distance from the Earth to keep it in a particular orbit. So wouldn't that, I'm trying to think. No, I was thinking that that the stuff from the Russian explosion could be going either in an X direction or Y direction that would be going towards the
it's a
space
spherical,
station or away from it, but actually it can go in any direction, right?
Yes, it's a spherical cloud of debris.
Oh my God.
It has two lobes. If you've ever seen some of those simulations of explosions in space, they'll generally have two equatorial lobes, which is the largest force coming out of it, clusters. So it'll have two lobes, but the debris field can be anything from something that might be a foot across to something that could be microscopic. And if you're going in the other direction and it's coming at you at 10,000 miles an hour and you're coming at it at 19,000 miles an hour, it could be as small as a pea, and that's going to do some damage.
You can imagine that as close as you are from Earth, the faster you orbit.
Yes,
so
yes.
just remember those little coins that you throw like in those cones to get like to go down in a spout. So as you started with your coin, it's like the speed is very low. And as it goes down into the spire, it moves faster and faster. So from this lobe of explosion, whatever's closer to Earth is going to move a little bit faster in many different directions. And then you have to imagine that if one of those debris are moving the opposite direction as the speed of the orbit of the space station, you could have something that moves way much faster than a bullet and you know, poking holes everywhere.
Yes, it doesn't have to be large to be damaging. It can be the size of a pea. But if it's, you know, if its sum of forces is, you know, 30 to 40,000 miles an hour impact speed, that's a lot of force. So that's the news. Did I miss any news items?
Yeah, they're thinking of changing the name of the Webb telescope.
No, they put in a request to reevaluate the name of the James Webb Space Telescope, given some comments that James Webb had made early on when he was assigned to NASA. And yeah, you wouldn't say those things these days, but back then it didn't even, you know, nobody batted an eyebrow to it. So there is a group that says, we shouldn't name the Webb after such a horrible individual. And there are others that are saying, do you know what this man did for NASA? Do you know that NASA wouldn't be anywhere near what it is today without the contribution of this particular individual? So it's, you know, it's about, NASA already came to a verdict that says, we are not changing it before it gets launched. We'll reevaluate it after it's successfully up there and doing observations. So,
okay. There's a long piece this morning on about it on the news.
I think that some people just enjoy stirring the pot.
Oh yeah.
I think that if you look at anyone back in that era, you're going to find something. Even if people
well, you know what Werner von Braun did, and he's honored, right?
Oh, you mean the lead of Project Paperclip? Yeah.
yeah. The guy who hung 6 Jews in front of his factory for Hitler to show what happens if you don't work fast enough. I don't think James Webb did anything bad enough to change the name. I mean, how ridiculous.
You mean the fact that we've got Werner von Braun and it actually in a photograph of him wearing an SS uniform, that kind of Werner von Braun? Yeah. I think that would take an even...
You remember that he was Secretary of State from 49 to 52. Someone who is like in power from 49 to 52 is bound to say something that nowadays is not.
And that's what I'm saying is, sure, admit that he said it. You can record the fact that, yes, back then, this is not the kind of thing we would be saying today. All of that makes sense. But to deny his accomplishments based upon what was acceptable back then, I think is, you know.
Yeah. I have to ask one thing more, Monroe. Since I sent you an article last week and you had already read it, and I sent you an article this week, or 2 of them, and you had already read it, and now you actually are familiar with the Operation Paperclip. Is there anything that I know or have read that you haven't done first?
It all goes in and never comes out, and I can call it up on demand rather rapidly. So I don't know. But I think it was rather interesting coincidence that I had already seen that video on YouTube out of just, you know, for want of something to look at out of pure entertainment, because I kind of understood the answer already. But for him to come away with that as the answer of, you know, electrons not really moving in a current, and then, okay, well, fine. And then to actually see on his same YouTube channel another video he did about electrons and transistors and saying that transistors control the flow of electrons. Like, okay, make up your mind. Do the electrons flow or not? That's why when he was doing the one about electron flow, he said, I know I'm going to get called out on this. Yeah, because you've got prior history that says you thought electrons flowed.
Well, they talk about charge carriers rather than electrons.
Yes. Oh, I mean, in his discussion about the transistor, he gets into electrons and holes.
Yeah.
What's a hole?
The lack of something. Yeah.
No, a hole is where an electron could be but isn't. So if you were to kind of ionize an atom and make an electron come off of the atom, the place where you could hold an electron is referred to as a hole. H-O-L-E.
Yeah, my Swiss cheese has some.
Yes, due to gas. Probably the same stuff that comes from cows. So this week is solving space junk. Next week, if I get the camera working and the astronomy drivers and such working, we'll do an update on the pan-tilt zoom surveillance camera being used for astronomy. On December 4th, I've got an update on photonic propulsion, specifically on photonic propulsion. We're not going to be talking about EM drives. There was a question that came up during the last presentation, and I have an answer for it. So that's what you'll learn about in that one. It was something that Helen pointed out about the vector of the reflection for the transferred momentum will be at 90 degrees to the surface. And I actually found products that changed that vector. It's called fiber optic cables. And they found this out when attempting to put fiber optic cables under the Atlantic Ocean. They found that the fiber optic signal didn't go as far as they thought it would. And then on Saturday, December 11th, we'll be doing our presentation on the James Webb Space Telescope. At least that's what they're calling it now. Along with our subject matter expert, Will, from the Space Telescope Science Institute. He's actually a instrument technology assistant. So he knows a lot about all the different instruments on the Webb, the Hubble, and Sophia. So there's that. And then on the 18th, we'll probably be doing an update on, did the Webb launch successfully? And if so, what is the state of its unfurling process? There will be no session on Saturday, December 25th or on Saturday, January 1st. So good evening. Tonight we're going to be talking about solving space junk. This is current in the news as of some debris that was created by an anti-satellite missile that is directly affecting the International Space Station and the humans that live aboard it. So we'll discuss that. Okay, there are tens of thousands of things in orbit currently about the Earth, and a week ago we got another 50 some odd courtesy of SpaceX Starlink. So they're now closing on 2,000 satellites in their system. The quantity itself is not really the problem because there's plenty of space in space to fit them all. We're not having any close encounters of things that we have in known orbits because the orbits have defined separations that prevent such things. But what we have is a lot of spent stuff that I'll just call junk. And we also have a lot of debris. And the debris is from very tiny bits of stuff. Every time we launch stuff up there, the junk pile grows, so to speak. Satellites that we send up there have a programmed lifespan of maybe about 5 years. That's their static container of fuel for keeping themselves in their orbital position. When you put stuff up in orbit, it doesn't stay there. It stays approximately there. But if you expect a satellite to always be in the same spot, you need to occasionally do things. Sometimes it's just orientation, which you can use a momentum wheel or a gyroscope to adjust that. But if you have to slide yourself sort of left, right, down lower or up higher, you generally have to use F equals ma in some kind of propulsion system to do that by today's rocket propulsion definition. Even if it's something that's being launched to the moon, there are boosters that might remain in high Earth orbit, that might go into elliptical orbit, that might be there for a long time. I believe that there is one of the Apollo boosters still in orbit about the Earth. So you put it in the right orbit, it can last for 100+ years easily. So these pieces are moving in orbit, which means they're moving at high velocity, greater than 10,000 miles an hour or 16,000 kilometers per hour, potentially in opposing directions, which doubles the collision force. Not only does this junk present a collision hazard, but if you have, let's say, a satellite that can no longer control its positioning, and it happens to be in a valuable geostationary slot in orbit, and you want to put up its replacement, how do you get it out of there because it's occupying valuable real estate? You can't put anything in there to replace it if it won't move or it doesn't have any fuel to move. Stuff that's in 8 orbits cross other orbits. So if you have something that's politely in a circular orbit, and then you've got something that's in a long elliptical orbit, those orbits can occasionally cross. And if you're in the wrong place at the wrong time, you can have a collision. So sometimes things that are in good orbits, in order for them to be well behaved, have to dodge things that can't control their orbit that are in bad orbits. And that's one of the things that these Starlink satellites do have from Spacex is they have their own ion thrusters, which they can use to not only keep themselves in their proper orbit, but can get out of the way of things. And they actually have onboard radar that allows them to detect it on an ad hoc basis. It doesn't have to be, get out of the way, something's coming, as told by the Earth. It can be, I've detected something on my orbital path, I'm going to move a little bit. And they can do that. So far, all of the mitigations or solutions to this have been incremental. I don't know if you read the article this week, but there is a new form of ion propulsion that instead of using xenon or krypton, actually uses iodine or iodine. But it uses it as a solid that it heats to a liquid and then ionizes the liquid iodine to use it as an ion propulsion engine. And because the iodine is solid, you can ship up a higher density brick of iodine than you can a pressurized gas spherical chamber of a xenon or a krypton. And also iodine is more prevalent, so it's cheaper. So they're looking at using iodine for ion propulsion in long duration missions. They haven't yet said about using it in satellite propulsion because iodine in that formula is actually toxic. So you don't want that becoming a fuzz around the Earth of poisonous iodine. The iodine you use in hospitals is actually a chemical compound. It's not pure iodine. There have been discussions about setting up fuel reserves purposefully to deorbit low Earth orbiting satellites. And I know that the SpaceX Starlink satellites do have this. They reserve a certain amount of their fixed fuel supply as end of life, push yourself back down in a controlled manner, burn yourself up over the Pacific Ocean, the Atlantic Ocean, or Siberia. And the materials that the satellites are made of are specifically designed to more effectively burn themselves up. So they're being a good neighbor. But what happens when you have a failure of components on board the satellite and it's a malfunctioning satellite? If it gets an engine stuck in the on position, who knows what orbit it will wind up in by the time it runs out of fuel. If it can't make its engines fire or it loses radio communication with the Earth, how do you get it to deorbit itself? You can't. You need something else. And what you need is something that can be a very long-lasting, very inexpensive solution to deorbit things. and it needs to work even if the thing you're trying to deorbit is broken. So the first possible cure that is being promoted is what is known as AKMs, or apogee kick motors. So if you've spent tens of millions of dollars for a geostationary satellite and you want to give it another 5 to 10 years of life, if it only cost you $2 million to put a rather dumb kick motor up into geostationary orbit to grab a hold of the back end of the satellite and push it up to a higher orbit, you know, and give it some fuel for another 5 to 10 years, it may be well worth it given the cost of the satellite and what it, you know, how much it costs to put it up there. So that's an apogee kick motor, but it only works on well-behaved satellites, and those satellites that are either prepared to receive a docking booster or ones that don't mind their rocket bell on the bottom being grabbed by one of these boosters. But launch delays are always inevitable. If you send up your AKM too late and it starts to get out of orbit and run into things before you can get your AKM boosted, you may not have a chance. And it'll only do this for about 5 to maybe at most 10 years because it's got the same fuel supply limit the original satellite had. And it doesn't work on satellites you got to go chase down because you won't have enough fuel on your AKM to chase it down if it's in a long elliptical orbit. You won't catch up with it. And it doesn't work on satellites or debris fields from explosions like anti-satellite missiles. Plus, it's a very expensive solution and it only works one time for one satellite. Well, if these only work one at a time and you say, I want to extend it another 10 years and you send up another AKM, can you, daisy chain these multiple on the back of the satellite, or will that change the center of gravity of the satellite and now it won't operate properly? Well, I'm going to take off the spent AKM. What do you do with that? You just created junk. And I'll put on the new AKM. What do you do with the one you just let go of? Well, if it's empty, obviously it's not coming back down. And even if it's not empty, you're in geostationary orbit. It takes a lot of fuel to push you all the way back down to deorbit you. So we need a better solution. So that's not really that great of a cure. How about space tugs? I've seen this in science fiction and people mentioning space tugs. This is same thing as an apogee kick motor, but at a different altitude. But it's going to have a net or a grappler, and it's going to drag the satellite back down and burn it up. Well, when you grab the satellite, you're going to change your orbital characteristics because you're now more massive. So are you going to be able to, in a controlled manner, do this? And if it's a satellite that's on an elliptical orbit, you're not going to have the fuel to chase it down. And if you're trying to do this for an exploded satellite, I'm sorry, your net's not going to be fine enough mesh to carry all the small pieces, and you're not going to chase down a large, sparse cloud of pieces. It's just impractical. And when you do this, one space tug dragging down one satellite is a 1-to-1, and it's very expensive. You need something that's going to work longer and with less of a financial penalty per deorbit. And then there's the capture and bring it home for refurbishment. This is one of the things touted as a capability of the space shuttle, is that it would be able to go up, open up the doors, deploy a satellite, and if they ever had to bring the satellite back home because it was malfunctioning, they could go up, open up the doors, use the arm, grab the satellite, put it in the cargo bay, and then bring the satellite back home. I think they did that once as a proof of concept and never did it again. I think that when you bring back something that massive, it tends to change the characteristics of the shuttle. For landing, there were a number of times that the shuttle landed rather heavy because of atmosphere and wind and things like that. But the idea is you send something up that goes up there and removes all the big bits from the satellite, solar panels, it just kind of flips those off and they go somewhere. They just become debris. Or if it's got a giant parabolic dish antenna, it clips that off so you can get just the electronic meat of the satellite you're trying to bring back for refurbishment, not to burn it up. Again, doesn't work for things that are in uncontrolled or highly elliptical orbits. It doesn't work for really heavy satellites in geostationary orbit because you won't have the fuel to get up there and enough fuel to get all the way back. It doesn't work for exploded satellites or sparse debris fields because you can't collect all the pieces. And once again, it's very expensive to send it up, and it's a one-to-one. You go up, you grab it, you come back down. Is it a refurbishable launch vehicle to do it again? It would be very expensive as we found with the shuttle. Now, maybe if SpaceX, if their spacecraft ever, grows its alligator nose to like open up the nose like that James Bond movie did and grab the satellite and then bring it back down. Maybe then, but I think they haven't thought about center of gravity because that would be on the nose of it, tons of satellite. And I think these kinds of things would only be deployed if there's heavy international pressure to spend the money. Otherwise, you get a financial penalty for leaving garbage in the neighborhood. And then here's the one that came up this week. Well, we'll just shoot it down. Not a good idea. It's just nonsense. It results in either lots of pieces if it explodes in a behaved manner, but most likely it's going to explode in an unbehaved manner, in which case various sized debris are going to go out in a cloud-shaped, dual-lobe, spherical thing that's it's just going to be horrible. So not a good idea. Now, Russia did have a good point that they did it, but we did it first. So the US was the first to do this back during the Star Wars program to prove we could shoot down things that were in orbit. Yep, we did it first. Then the Chinese did it, and now the Russians have done it. Apparently, every major nation that has launch capability has to prove they can blow up satellite.
That's stupid.
It's stupid. It's military nonsense. If they really just wanted to incapacitate a satellite, a laser or an electromagnetic field would work just fine. And it wouldn't blow up the satellite. And it probably wouldn't do much to its orbit. But I have a thought. We know that radiation reflective pressure does work. It can move things. Otherwise, solar sails wouldn't work. We know that lasers are a great way to slowly decelerate things like, I don't know, molecules when you're trying to super cool things. How about using a laser to deorbit debris? Now, you could position a laser above the targets and then point them downward at the targets to not vaporize them or burn them up or ablate them away, just to nudge them. And you would do this multiple passes. If you're higher in orbit to something lower, the thing that's lower is going to go around several times to your slowly going around once. So as it went around, you could zap it, zap it, zap it, zap it, and slowly push it down. And by doing that, you'd have a controlled descent. Now for junk, instead of focusing it down to the size of the satellite, make it a broader beam and just do it more often. It shouldn't take more than a few kilowatts if you're in orbit above it to do that. So not, something that's going to be harmful to us here on Earth. If you had a laser that was in the near ultraviolet, but not into ultraviolet wavelength range, that would transfer maximum momentum without causing difficulties in your focusing and tracking mechanisms. And since you're towards UV, it would be very difficult to get a beam that's widely dispersed all the way down to the Earth, because the water vapor in the atmosphere would scatter that field and not make it back down. It's why you get burned by a certain wavelength of ultraviolet light, but not the horrible stuff. So UVA, UVB, UVC doesn't make it down. So you would need to focus the beam to something that's small enough to the satellite. And we can do that with a laser, but you need to focus it. And if you want to focus a laser, you're going to need mirror and you're going to need lens. And so you have to make sure that those work and are compatible with whatever wavelength of laser you pick. You put the laser slightly above geostationary orbit. So it would actually be orbiting slowly, slower than the rotation of the Earth. So you could catch different kinds of orbits. Anything low to geo, you could focus down on them. And anything that was elliptical, every time it came by for a pass, you could beam at it. And the Earth would be rotating underneath you. So you would have more opportunities to hit all the stuff below you. If you were to go and say, well, why don't we just use the shortest wavelength possible? Why not deep UV, like UVC, or X-rays or gamma rays? Mirrors and lenses that are made out of glass are fairly cheap and easy to come by. Once you start getting into deep UV, X-rays or gamma rays, photons behave differently. Let's say you wanted to use deep UV. You couldn't use glass because glass blocks deep UV, blocks UVC. You have to use different kinds of materials in order to transfer UVC through your lens. So let's forget UVC. But what about X-rays? Shiny mirrors and glass lenses do not work with X-rays. You have to use magnetic field coils. And that gets to be much heavier to launch into space than a mirror or a glass lens. And gamma is just way too much energy for even that. The best you can do with gamma is you have dense blocks that absorb what you don't want scattered in your field. So yeah, we have X-ray satellites that can observe in X-ray. We have gamma radiation satellites that can observe in gamma, but those are specially designed and they have magnetic field coils to direct the X-rays, and they have dense blocks that act as kind of a channel or a waveguide for the gamma radiation. So what we should use is something that is not quite UV. And my recommendation is either royal blue, which is at 440 nanometers, or closer to UV, but still can be bounced by glass mirrors and focused by glass lenses, which is violet at 415 nanometers. When you get down into the 405 to 400 nanometer, you start needing special materials if you want to reflect or focus. And I know that the mirrors become what they call cold mirrors, and they're gold-plated mirrors. So that makes them far more expensive. So what would the process be for deorbiting something? Well, you would gradually nudge it down. You're not going to vaporize it or ablate it away. So you put this in orbit, and if it's in a nice higher than geo orbit, it could be up there for 100 plus years. If you give it a little bit of a fuel tank and some large solar panels, it would have more than enough power to do this for quite a long time. You would give it a list of things to deorbit: satellites, debris fields, and every time the object passed beneath it, it would, very quickly switch the beam off and on to give it that shotgun effect to push on it, and it would slowly come down. Now, if the object is rotating, if you're rotating this way and the object's coming at you this way, you want to angle the beam so that it degrades. It creates a negative delta V to change the orbit so it starts coming down. And if it's facing the other way, then you probably want to hit it on the backside to change its orbit, to change the delta V in the other direction. Because remember, if you're going faster, you're in a lower orbit than if you're going slower. It's counterintuitive, but that's just orbital mechanics. As you nudge it down further, you want to make sure that if there's something at a higher orbit that passes between your beam source and the thing you're targeting, you have the beam switched off. You don't want to inadvertently, add a little reflective pressure to deorbit something that's unintended. So you want to be switching it off and on very quickly. You'd get a schedule of the orbits. You'd say what you're going to be taking down, and you just over time, slowly degrade its orbit until the atmospheric friction starts to reduce it faster. Another thing you can think about doing is if you have something that's uncontrolled, that's got a spin to it, you can actually hit the beam on it to retard the spin and stabilize it. So if you have a otherwise functional spacecraft or satellite that is just spinning and you can't communicate with it, if you can stabilize it so it's no longer spinning, you might regain control of the satellite. Who knows? But never do it and try. But then again, shortly before it starts to deorbit and burn up, if you could use the laser to kick it, to spin it, it would make the burn up more efficient. This is a little bit of a numerology here, but if you were to calculate the altitude versus orbital speed distance versus the angular degrees per second and the orbital period, this would give you an idea of how complex it would be to have a laser go to and track a target. If you're in geostationary plus orbit, your orbital period would be like 26 hours or greater than a day. If you're trying to deorbit something that's on low Earth orbit, it's going to go by every 2 hours. So you have plenty of opportunity to hit it many times in a single day. But you need to make sure you don't hit anything on the way down. And you need to make sure that you kind of slam it a couple of times every time you have the opportunity to hit it. So you're going to be switching the beam rather quickly. A better place to park it instead of high geostationary would be, we've discussed Lagrange points. If you remember, the James Webb Space Telescope is going to be at the L2 point. There's another point called the L1 point, a very bad place to put your infrared telescope, because one side of it would always be facing the sun and the other side of it would always be facing the Earth-Moon system. This would be an excellent place to put the laser, because it would always have the sun at its back, so it could always have the solar panels pointing at the sun without having to tilt them as you orbit the Earth. The Earth would be rotating beneath it, and you could target things in any orbit. And another benefit would be, gee, the moon orbits below you as well. So once we start putting more junk in orbit about the moon, as we start, launching and landing things at the moon is smaller diameter, so the orbital station's opportunities are reduced. So you want to get rid of the junk. Well, what are you going to do with the junk? Well, the moon doesn't have much in the way of atmosphere, but it does have gravity. So you'll have to push a little harder in order to deorbit things orbiting the moon. But, putting the laser at L1 would be very good. And if you put multiple lasers on board, it could actually deorbit multiple things simultaneously. Now, if you put it exactly at L1, then the antennas on the Earth wanting to talk to the satellite can't, because the sun's in the way. So you might want to put it in one of those funky halo orbits, so it orbits about L1, but that would cost a lot of fuel. So put it L1, and we'll just use the TDRS satellites in geostationary orbit about the Earth as relay satellites to communicate with it. We won't try and point the radio antennas directly at the satellite. Now,
what about if you use three spacecraft in a more linear orbit? So you could cover the whole planet with that.
Yes, but your beam would be much farther away at the apogee of your orbit and much closer at the perigee of your orbit. So a millennia is going to be very much closer to a lunar distance orbit, and therefore you still need a high power laser. I think the stability of L1 has merit, and the fact that you always have 180 degree by 180 degree field of view of the Earth gives you plenty of opportunities to take out any orbit you want to take out. And since we're not doing imaging with this satellite, the data rate is likely to be for scheduling and status communication. So we could use an S-band transmitter. You wouldn't need to use that high capacity X-band transmitter like the Webb is using. So I already read all these through. But here's ones that I left out. If you want to track a satellite that you're trying to shoot down, if you're in orbit about the Earth, your imager would have to work in both infrared and visual. But if you're always at L1, you've always got the sun at your back, and anything you're trying to target would always be in sunlight. So if you're using cameras for targeting, they would always give you a nice reflective view of your target. Same thing would be true if you're trying to take out orbital debris about the moon. You would catch the moon as it's orbiting on the sun's side. So there's benefits to being at L1. How much beam power are you going to need? Well, as we all know, the amount of flux or photon density per square area is going to be different as the distance increases. So at L1, you may need a megawatt class laser. You're obviously going to need larger mirrors and lenses and a longer focal length to make the beam smaller by the time it hits a low Earth orbiting satellite. So maybe we start at medium Earth orbit where there aren't many satellites, and we do a proof of concept launch with a Falcon 9. So once we've proven that this is beneficial, and maybe even SpaceX in conjunction with NASA would like to fund something like this. So here, if they watch this video, here's a bug in their bonnet. Now, once it's been proven technology, if they want to put something at L1, it would benefit all nations on the Earth. You would no longer have to take down your own satellites. This could take them down. Maybe there would be an international consortium that could be funded by either contributions from various nations or a service fee to take down your satellite based upon, is it geostationary, is it low Earth orbiting, is it under control, not under control, is it ammonia orbit, is it a nice circular orbit? You know, ask all those things and then charge the appropriate fee. But I would say an international consortium makes sense to do this at L1 because it's going to cost more to get it out there. And do ask China and Russia. I think it's worth their while to do it. So avoiding this satellite being its own example of enemy, you want to use redundant everything so that the thing that you put at L1 stays there for a long, long time. If you are stuck with fixed capacity liquid fuels and momentum wheels, this thing is only going to last about 10 years. So you need to start thinking about maybe, ion propulsion, scavenging solar wind instead of having a fixed tank of xenon or krypton or iodine. So you got to move away from that because we want this thing to last 50 years. So you have to have redundancy. You might want multiple lasers on board so that you could simultaneously take down multiple satellites. Or you could, if the laser is really powerful, you might want to have it disperse heat into space before firing again. So that way you could sort of a Gatling gun style to avoid the barrel melting. You have multiple barrels. Or you could have multiple lasers fire on the same target simultaneously. So, conclusions. Earth orbiting space junk is an increasing problem. It's not a matter of how much space we have to put legitimate things up there. It's the junk. It's not a can to be constantly kicked down the road as we create new junk, ignore existing junk, park geostationary satellites in a less expensive orbit. In the absence of any international regulation to clean up your junk, organizations and governments that launch junk are just not going to deal with it. And blowing up stuff just makes more uncontrollable junk. Space tugs and apogee kick motors just are not an effective solution, and they're too expensive and they don't work on debris fields. Lasers can push things. Let's use them. A couple of kilowatts in geostationary should be sufficient. Not quite ultraviolet. As the beam distance increases, you need something to narrow it down smaller. But once it gets below low Earth orbit, it's going to be wide enough diverged or dispersed or diffracted that it's going to be safe for aircraft. You need to be able to task the beam to multiple satellites at multiple times so that you can just slowly push them down. Parking it at L1 makes sense. There's a lot of benefits to doing that, but it's going to require a more powerful laser due to the increased distance to target. So plan it out. But I did not see this on the decadal survey the U.S. just recently published as, what are you going to do about junk? Everybody just said, we're going to launch more junk. Okay, and I've got a couple of links in the presentation for if you need more information on how UVC is blocked by the Earth's atmosphere, the benefits of an L1 point. If you want to go back and say, if I want to orbit something at this altitude above the Earth, how fast would it have to be going? So there's actually an orbital calculator for doing that. And why shooting things down does not make sense. So, any comments or questions?
What is the name of the syndrome? They say that one starts to bump the other, who breaks apart and destroy all the satellites. Kessler or Chrysler, something like that.
Kessler.
Kessler syndrome, yes.
Kessler syndrome, yes. If you think about nuclear fission, the idea is you create a chain reaction. You know, one thing hits another thing, which creates two things, which creates more things to hit other things. And the Kessler syndrome is if we have a large enough collision, creating a large enough sphere of debris, that debris will interact with other things in orbit, and therefore you'll have a cascading effect. You'll have a chain reaction, which will create a debris cloud around the Earth, making Earth orbit no longer viable for satellites or spacecraft. This is a worst case scenario. There is a probability it could happen, but it's a low probability at the moment.
For now.
At the moment. We keep putting more things up there, the probability goes up. We keep leaving more junk up there, the probability goes up. We keep doing stupid, like blowing up satellites, the probability goes up higher, faster. Satellites in orbit, that's fine, I'm okay with that. But clean up your junk and don't blow it up.
Any questions?
Questions? Comments?
A comment.
Yes, go ahead.
All right, question, I guess. I don't, I hear you saying that you're not opposed to them sending more stuff up there, but everything they send up there becomes junk eventually.
No.
So
no.
I'm opposed to it.
No, if you look at what SpaceX has done with their Starlink satellites, they have a purposed lifespan of 5 years at most, and they've already sent down a single-digit number of satellites on purpose to prove that their calculations are correct. So as they orbit first-generation satellites, each one of those satellites has a planned lifespan and deorbiting. They have a couple of the satellites that never made it to their target altitude, and I think they need a solution for that. Now, whether it's a space tug or a laser pushing them back down, they need a solution for that problem. But as far as corporations that put stuff up, that police their stuff, I think that SpaceX is currently ahead of the pack. There are no commercial satellite vendors that put things into geostationary orbit that have ever brought any of their satellites back down. They've all just parked them in another slot in geostationary orbit at the same altitude. Just, we'll do it over the Pacific or over the Atlantic or over Siberia. All the prime spots above all the continents where there are lots of customers with antennas like, satellite TV receivers. Well, that's the prime real estate. They want to get the old satellites out of there. And that's where the apogee kick motor concept and the space tug concept came in, is they need to get those out because it's not the satellite that they're removing that is cost effective to reuse. It's the slot that the dead or misbehaving satellite is in. They want to get it out of that real estate, either bring it back down or put it in some other spot that's less expensive real estate. I think we're probably many tens of thousands of satellites away from, kind of running out of real estate. But I think that all the satellites need to police themselves.
They are taking up space in those slots, right? I mean, even if it's a tiny little space, we can see that they keep doing that. They're going to take up the whole parking lot.
There's a long way to taking up the parking lot.
how about engaging the expired SpaceX satellites, the Starlink satellites, to retrieve another satellite? As long as it's going to deorbit itself, why not pick up another one on the
good
way?
idea.
They're too small. If you've ever looked at one of the Starlink satellites, the Starlink satellites are about the size of a ping pong table. If you took two ping pong tables and laid them one on top of the other about that thickness, that's roughly the size of the body of a Starlink satellite. And their ion thrusters are very anemic.
So then it wouldn't have to pick up a big satellite. It could pick up a smaller yet dangerous piece of space junk on the way down.
I don't think it would be practical.
Or 2 or 3 pieces.
I don't think it would be practical to do that. I don't think they'll have the propulsion. I don't think they have the propulsion capacity for doing that. I'm very happy with them deorbiting themselves.
Well, maybe the current ones don't have that technology, but maybe future ones could, since they're already up there in space.
Yeah.
Why not just add a little bit of technology for them to be able to do that?
Well, the thing is that you have something that needs to navigate in space. You have you have to have systems where you have propulsion. So you can have hydrogen or any kind of gas to actually go the split thing, like and control the direction and move. So when they're doing those satellites, they're doing like really small satellites so they can launch a bunch. And if you make them a little bit larger, it ceases to be economical for them to actually do that. So their navigation systems are extremely, small, and they cannot really navigate easily around the orbit of the Earth. If like at least every satellite from now on being launched with something that has a system that can deorbit themselves, at least avoid to add to the plot problem. But I don't think that you sending something else to actually navigate. And even though we are worried about the real estate there, the spaces that you have around the orbit of the Earth are huge. And for you to navigate, for you to have enough combustible, enough propulsion system to actually navigate where it needs to go to get another one, see the speed that it's moving, avoid collision, and actually the orbit, it's extremely complex. So I think first thing first, whatever stuff that's being launched needs to have a deorbit system.
Yeah, the other thing to consider is that not only are these Starlink satellites in low Earth orbit, they want to be even lower. SpaceX has already filed with the FAA to make their satellites about 100 kilometers lower to reduce the transit delay of the radio signals, which would make them deorbit faster. If you've seen the amount of time it takes a Starlink satellite to go from launch to being in station and where they expect it to be, it takes several months at their low performance propulsion system to get them up to where they need to be. So I don't expect Starlink satellites to push anything else down. Also, they can't get up to geostationary. That's quite a bit higher in orbit than they have the total propulsion for. I think that the cost effectiveness of trying to take something that you pushed up to geostationary orbit and getting it all the way back down from geostationary orbit in a controlled manner, I think that commercial vendors will just find a way to exert political pressure where they don't have to do that, because that's just going to be too expensive. You have to put too much hypergolic fuel on board the spacecraft, which increases its explosion potential.
So am I correct in thinking that most of our junk is higher than where SpaceX is going to be?
No, it's all over the place.
Oh.
There's junk at all altitudes and in all orbital planes. So depending upon the size of it, if it's something large that's in a controlled trajectory, like a rocket booster, it's going to be up there for 100 plus years. We'll just make sure that nothing else gets that entire orbit. If it's on an inclined orbit, same thing. If it's a debris field, well, we're not going to put anything in the debris field, but as the debris field itself is orbiting, that creates a swath that we can't put anything in. So we need a long-term solution for the problem, and we need the ability for it to be effective at both individual whole objects of very large size rocket boosters, all the way down to very sparse debris fields, and push all that down. So that's why I came up with the solution, is identify a problem it doesn't solve. And I couldn't think of any.
Say that again.
You have to be able to deorbit very large things like boosters. You have to be able to deorbit very large things in geostationary orbit like communication satellites. You have to be able to deorbit things that are not controlled because they malfunction. They're on a weird orbit. You have to be able to collectively bring down debris fields that can be sparse, that can be very spread out. And you can do that with a beam that you repeatedly push on the entire debris field, kind of like shining a big bright light on it. You can't do that with an apogee kick motor or a tug.
Okay, so now when I talk about one time, I'll say something like you'll say about junk, and you'll say it's all over the place, and it doesn't sound like it's very far away from each other. And then I say something, and then it's like they're all too close or they're all too far away. So my understanding right now is that there is a lot of junk up there, but it's not very close to each other. And so there's a big problem on sending something up there to do one job and then on its way back to pick up something, because it won't necessarily be in the same area the junk is.
Correct. And think of it like if I throw a football into the air and I want you to take out that football, it's one fairly large thing. Now it's a celebration and you've got a confetti gun and you blow off a load of confetti. I want you to pick up every piece of confetti before it hits the ground. Yeah. You've got to solve both of those problems.
But one of the things is that if there's confetti going up in the air, and you have an area that's been designated to have that, then you send in the crew to clean it up because you've been prepared for it. But we haven't been prepared for this kind of junk up there to have to bring it down or clean it up. It's sort of like the ocean also. It's like, there was a big ocean and people say, oh, you can throw that in the ocean because, hey, it's a big ocean. But it's not that big when you get started, and it seems to me if we could start now and do something. But what I hear you saying is that we shouldn't focus on what's up there so much as to focus on making sure we don't make any more junk.
I think you should focus on both of them. You've got to eliminate the junk that's already up there. The big stuff, the sparse, dispersed stuff, you've got to have a solution for both of those. And you've got to make sure that anything you send up now, that you give it enough fuel so that it has an end-of-life deorbiting capability. And if you can't do that, then you should be paying an international fee for someone else to clean up your mess.
Now, is that proposed at this current time, or are people paying attention to it?
The UN.
Some comment that is like few people who worry about that, but they look at people who says that like tree huggers, kind of thing. It's like, it's big enough, don't worry about it. Like the analogy that you did with the ocean, so it's just perfect. It's big enough, it can have enough, dirty patches of plastic. And same thing is for spacecraft. The way that you have the real estate, that real estate's free for you because you got there first. And it's a very valuable real estate. Now the cleanup, everybody needs to pay. But you made your money with something that was free because you put your flag first and you have your homestead in space. But then you left your trash there and you're asking for the states and for the public who uses the service to pay for it. So it's kind of funny that, let's not regulate. But then when you need help to let's put everyone and let's put the state to help you. It's like, it's not fair. It's just, this is really trash in space, trash in the ocean, trash in your own city is a state solution. Is a we need regulation to do that.
Well, we already know that there are certain industries that count upon government to clean up behind them at no cost to them.
At least he's making us think about it, though, too, about what's going on.
Yeah. And there's certain things he can do something about, even if he contributes billions to it, like changing from internal combustion engine to electric vehicles. He can make that happen. But, solar power in your home, even he's had a tough time making that effective. He's doing it.
He's sending up, you're saying the skylight, that they are sending them up with the idea that they won't be junk up there. And that's a very good step in showing other people that this can be done. Because a lot of times people just say, oh, we can't do anything about it. Well, that's not true.
He's doing something about it. But you also got to think about the method to his madness, which is if the US government is assigning him certain orbital slots and his satellite is in that slot, and that's a generation 1.0 satellite, what's the easiest way for him to get a generation 2 satellite into that position? For him to not give up the position and just deorbit the first one and put the second generation in its place. So he's reusing his own orbital positions.
So he was motivated.
He's recycling. He's deorbiting. He's deorbiting it. He's creating the spacecraft with more effectively, burned up things with less hazardous waste on them. And he's reusing the slots he's been given. So,
and you're telling me he was motivated to think about how his slots are being used and to not do junk.
I think it was more about, how do I reuse the slots? I'm not going to get more. Well, if we deorbit them and we deorbit them so they're not toxic, they're more likely to let us reuse our slots. So I think he started with once this satellite's no longer useful, how do we get the approval to use that same slot? And you never give the slot up. So when he talks about his Starlink program may need 40,000 satellites, that's for the duration of the program. He probably needs less than 10,000 satellites to cover the entire Earth. But over the lifespan, over multiple generations, it'll be like, 10,000 satellites every 10 years. But there won't be additional, there'll be replacements.
It's good that he's thinking ahead.
Yes.
And that it's good that he's doing that so he can set examples to others.
Yes.
Yeah, it's excellent. Of everything we talked about recycling and what companies are doing and happening, it's the only one that isn't fake.
Yeah. Okay. Done with this presentation? Stop recording?
Yes. Thank you.